righty, well, let's go ahead and get started. I would like to introduce to you Maria Tackett. Maria Tackett is an assistant professor of the practice in the Department of Statistical Science at Duke University. Her research focuses on examining factors that impact students' sense of belonging in introductory math and statistics courses, along with identifying pedagogies that foster community and supportive learning environments. Maria has worked with the Bill and Melinda Gates Foundation and the Charles A. Dana Center on projects to develop introductory statistics courseware and instructional materials. She is an associate editor for the Journal of Statistics and Data Science Education, an editor for the Taking Chance in the Classroom column of Chance magazine, which I just waggled there, and part of the steering committee for the current Gaze College Report revision. She's also a mom of twins. So take it away, Maria.
Great. Thank you, Jennifer. Let me take a moment to share my screen and hit play. Great. Okay. So hopefully everyone can see my slides. So thank you, Jennifer, for that introduction, and thank you to the eCOTS committee for the opportunity to speak today. I spent some time in industry as a statistician. Now that would be called a data scientist. And so when I moved back into academia and started teaching, my experiences in industry and the skills that I had to use to be an effective statistician or data scientist in that job really shaped and made me really think about, well, what are the skills that my students really need to use the statistical methods once they leave my classroom? And so the talk today is based off of, I'll share some ideas that I hope will continue to contribute to this conversation, just based on the different presentations and discussions I've seen at eCOTS thus far. I know that many of you are thinking about these ideas, and so I hope that this is just another piece of that conversation. And so let's think about our students' experience. They're in our statistics or perhaps data science courses. We're giving them lectures, teaching them statistical methods and how to work with data. They may practice and homework and exams, and usually there's some sort of final project in which they're putting together everything they've learned to analyze a data set of their choice. And so they're getting lots of practice and they're learning methods of statistics in their classrooms, but then at some point they walk out of our classrooms and they enter the real world. Now, some of you may recognize this logo as the logo for the popular reality TV show in the 90s. And as part of this TV show, they would always sort of explain what the show is about in the opening credits. And there was one line in particular that I think, with slight modification, really nicely describes the student experience as they leave our classroom and enter into the real world. And so once they enter into this real world, right now they're dealing with issues like having to calculate summary statistics from a column in which there are dollar signs. And how do we get rid of the dollar signs? Because now my computer program thinks this is character data instead of quantitative data. Or wait, there are some missing observations. How do I deal with the missing data, and how do I account for that in my analysis? Or perhaps they are a parent and they're at the doctor's office and they have to look at this growth chart. So this is a growth chart for boys ages birth to 36 months. As Jennifer mentioned, I have toddlers, and so I've looked at a ton of these over the past year. And so they have to understand, their child is in the 5th percentile. Well, what does that mean? And what are the implications for their child's care? Or maybe they're the medical professional having to explain to the parent what it means that their child is in the 5th percentile. Or perhaps now they're in an environment where they have to collaborate and work on a team. And do they know how to deal with some of the conflicts that arise as they're navigating working with people with lots of different personalities and experiences and perspectives? And even, do they know which tools to use, and how, just like logistically, how do we work together in collaborative data science work? Or maybe now they're confronted with these issues of ethics and they're thinking about, well, how is my data being used to contribute to these large language models? And how do I consider data privacy in this age of sort of big data, and especially now with AI? Or maybe they're on the team at OpenAI or some other company developing these large language models, and they have to think ethically about responsibly using data while also trying to fit the best models that they can. And so there's all of these sort of challenges that exist in the real world. And I think there's some gap between what students are experiencing in our classroom and what students are experiencing once they enter in the real world. And I'll say it completely makes sense that they get a more quote unquote polite experience with data and all of these issues in our classroom, because we need to teach them statistical methods. We already have too much content to cover in a semester anyways. And so we can't also give them a full real world experience. But what I'm positing is that perhaps we can equip students with the skill so that what they're experiencing in our classroom is maybe just a little bit closer to what they're experiencing in the real world. And so one big piece of this are the methods that we're teaching them to process and visualize and analyze data. And here we see just a representation of many of the text that have been written. These are primarily at the introductory level to teach students a modern approach to think about statistics or methods. And there's been a lot of research and lots of people working on thinking about what are the actual methodological content that we should include in our courses. And so this talk's actually not at all going to be about statistical methodology. What I want to talk about are what are those other skills besides the statistical methods that help our students be more effective as they're applying all those methods that they've learned in the real world. And these quote unquote other skills fall in 4 categories: computing, communication, collaboration, and ethics. I tried really hard to find a word that started with C to represent ethics, and I was unable to. So perhaps if you have suggestions, you could put that in the chat. But I feel like ethics really grabs the culmination of what I'm thinking about in this area. So we have the 3 C's and the E. Now, you don't need to read everything on this slide, but this just shows statements from some of the curriculum guidelines and statistics from the ASA and other organizations about what students need as they're coming out of their statistics and data science programs. And so they talk about students needing facility with professional software and other appropriate tools. They need the ability to communicate statistical methods in basic terms, because they're going to be talking to managers and other audiences who perhaps don't have as much statistical experience. They need to demonstrate an ability to collaborate on teams as well as organize and manage projects, as well as exposure to an ethical training and sort of how do they grapple with issues such as data ownership, security, transparency, and reproducibility. And so these skills are not just for students who are going to graduate with like a statistics or data science major, right? As stated in the 2014 guidelines for undergraduate programs in statistics, the statistics is a universal discipline. And so this is not just for those students who were preparing to do some sort of directly related statistics or data science work. These skills are really for everyone. And I think this statement is even more true now than it was in 2014. And so really the skills that I'm talking about today are skills that are beneficial for students to learn, whether they're preparing to be a statistician or data scientist, or if they're preparing to be an art historian. There's something there that all of our students who are sitting in our classes can benefit from. And so what I'm going to do is talk about each one of these skills, provide some examples or strategies and how these have looked in my courses. And I've broken this up into sort of 4 different sections, but really you'll notice throughout that these skills really all sort of there's a lot of interplay with one another. And so in talking about one, I probably will end up talking about another, but I've organized this into sort of thinking about these 4 different skills. And so we'll start with computing. And so as stated in the 2010 paper, Computing in the Statistics Curricula, really one of the primary goals of teaching computing and information technologies is really to remove obstacles to engagement with a problem. And so in addition to students learning how to use these professional tools, learning computational thinking, really the computing gives students the tools they need in order to engage with some of that messiness that may occur as they're working with quote unquote real world data. And so in thinking about teaching computing, really this is again the opportunity for students to gain experience using these professional tools. So they're already gaining experience with the tools that they perhaps may encounter as they start research or go to internships or their careers. It gives them the ability to work with really more realistic and complex data. So by using computing tools that are commonly used outside the classroom, they have the opportunity to sort of explore more realistic and complex challenges. It also helps them develop a reproducible workflow alongside learning statistical methods. And so it just becomes ingrained, almost like riding a bicycle, that reproducibility is part of doing any sort of statistical or data science work. And so I would say, and others have said this before, giving students experience, or I'll say at least exposure to computing in early courses is really important to help achieve some of these goals. One, it helps students incorporate and learn more advanced skills in their subsequent courses if they do decide to pursue further study in statistics or data science. I have taught courses throughout the statistics curriculum from the intro level all the way to upper level undergraduate electives. And I have seen the payoff in those upper level courses as we've been able to do more advanced things or more complex things because students had spent multiple semesters developing their computing skills. This also gives us an opportunity to reach a broad and diverse student population. The biggest group of students we'll ever teach are in those first and second courses. And so by giving students experience with or exposure to computing early on, we're really equipping a broader and more diverse student population with these really important skills. And so now I'll provide just a quick example from an assignment from one of my courses on really how computing helps students more deeply engage with an analysis question, sort of beyond maybe sort of the basic conceptual piece. So here's part of an assignment in which ultimately students were looking at the relationship between the political leanings of a county and the percentage of in-person votes in North Carolina. And so if you think back to the 2020 election, there were lots of debate about whether or not it was safe to vote in person due to the pandemic. And there was some view that there were sort of political divides and the safety of that. And so we explored this for North Carolina because that's where our university is located. And so we start by just looking at the distribution of the response variable, and students start by looking at a histogram, right? So something that they've seen time and time before, and they can understand the shape of the response variable, and they notice perhaps there's some outliers, and they can understand, sort of the spread of the data. But you might already suspect, right? We're dealing with county level data, so perhaps there's some spatial dependency we need to think about. And so students also looked at the response variable on a map, and they thought about, well, what do I learn from this map that I didn't get from the histogram? But also consequently, what did I learn from the histogram that I didn't get from the map? Now, teaching spatial visualization is not a part of my course. This is a regression analysis course. There were some students who had seen it before in their data science course, but most students had not seen or had experience with creating spatial visualizations. And so in this case, I actually provided the students basically all the code they needed in order to build the map. The histogram they could do on their own, they had seen before, but for this map, I exposed them to really, what the computing tool could do beyond maybe like the histogram or such. And so you notice perhaps that really for this exercise, all the students had to fill in were the labels. So they just had to label everything and take a look at the code and they could produce the map. Now, later on down the road, they fit a linear regression model, again, looking at the relationship between political leaning and the percentage of in-person votes. And then they needed to plot the residuals on a map because we were checking the model conditions. And again, our spidey senses go that perhaps there's some issues with spatial dependence. And so here they make a map of the residuals. But because they had been provided with the code early on, I didn't provide code for this, but as part of the instructions, I said, hint, start with the code from exercise 2. And so this was just a small way for the students to then get some experience on their own, building out some spatial visualizations. Most of them perhaps just copied and pasted the code, but then they had to at least think through, well, which variables do I change in order to plot the residuals instead of plotting the response variable, and how do I relabel things, etc. And so again, this is a small example of the way in which computing sort of removed an obstacle in order to engage with the problem, engage with this idea of the spatial dependence that I've seen exist in so much data that students want to use for like final projects or want to explore. But then also an example of a way in which I expose students to something that was, again, not part of my core learning objectives, just to show them what they could do sort of beyond what we went through day by day doing linear regression. And so the next skill that I'll talk about is communication. And so here's a blog post by a VP in data science and analytics at a tech company. And the title of her blog post was "The Most Underrated Skill in Data Science, Communication." And this quote from her post, I think, really nicely explains the importance, or what's the value of communication, right? She says, communication is the competency that's often the difference between a truly high-performing data scientist and a data scientist who's just simply good. And this aligns really closely with my experience in industry. And I know as educators, all we do is communicate. And so I'm sure I don't have to convince you the importance of communication. But I'll reiterate that this is not only true for data scientists. You could insert any job title there. And communication is really what helps take someone from being simply good to being like truly effective in their work. And so I'll focus on written communication at this point. I'll talk a little bit about oral communication later on. But when I think about teaching written communication, I really think about it in sort of 3 prongs. The first is from day one, just getting students to produce professional looking visualizations. This means you have the axes labeled, you have a clear title, everything's readable, professional looking output, really just taking that extra step to take things from the kind of computer looking format to a nice, neatly printed table. And then also reports. So organizing your homework so it's clear where exercise 1 is versus exercise 2, etc. And so we really start that from the first day they see an example of what organization of a report and visualizations, etc. And then, this is a statistics class, right? So we're talking about the accuracy of interpretations and conclusions, and, how do we get this output, get these visualizations, and how do we accurately interpret those? And then we move on to effective communication. And so this is really, I had a manager who called this the what's the so what. So you know that you have a low p-value, but like, again, what is the implication? What does this mean for my business decision or the care of my child or whatever the issue is? And so we really think about these in 3 parts. And I'll give an example from an assignment that occurred later in the semester. So by this point in the semester, students have seen multiple examples. They've done multiple assignments at this point, sort of seeing what all of this looks like in practice. So this is not their first engagement with these ideas. I'll also note this also happens to be another political example. So this is perhaps I'm showing the types of topics I'm interested in, but this is from a different semester. So I do try to limit the politics to maybe once or so a semester. But this was an example in which students analyzed data from a 538 article called "Why Many Americans Don't Vote." And they were looking at the relationship between political party identification and voting behavior of adults in the United States. So really in the last few elections, how often did the adult report that they voted? And so the first thing they had to do was take a variable party ID, which was the person's party identification, and collapse it down into 3 levels and visualize the results. And so here what they're doing is doing some data processing. So this is going back to that idea of sort of what do we gain from using the computing tools. And so they had to take the survey data, which had like 6 or 7 different categories, and collapse it down to basically Republican, Democrat, or independent, or neither. This was one because a lot of the other categories, like unaffiliated or unknown or etc., or refused to answer, had very few categories. We also chose these 3 categories to be consistent with the shape of the analysis in the 538 article. And then they looked at visualize their results. So from the beginning of the assignment, I have students do some light data processing and do some sort of visualization, mostly just to kind of remind students that this is part of the data analysis process, as opposed to kind of already preparing this for them in advance. So then from there, they fit an initial logistic regression model, basically to predict whether or not a student or adult reports themselves as being a frequent voter. And then they're fitting a model that's taking into account demographic characteristics such as age. I think there's things about education level, etc. So we're trying to get rid of all the other confounders. And then now they need to consider whether or not our variable of interest, party ID, should be included in the model. So they conduct a hypothesis test. We're doing logistic regression. So they conduct a drop-in deviance test and they produce some output. And you may notice all the way on the far right, the p-value 0. And so here the students are asked to conduct this test and then just tell me if political or party ID should be in the model. And so then here is a student response. The emphasis is mine, where the student says, the p-value is approximately 0. Since it's very small, we reject the null hypothesis. The data provide evidence that there's at least a coefficient for party ID not equal to 0, but ultimately we get to okay, we should include it in the model. And so this is really the accurate interpretations and conclusions piece. Can the student take the statistical output and just interpret it correctly and come up with a correct conclusion? Well, this part's nice, but ultimately we want to get to understanding, what's the relationship between party ID and voting behavior. And so then students are asked to write a short paragraph, just like 3 to 5 sentences, that are summarizing this relationship between the party identification and voting behavior. And so here's where I'm looking for the effective communication piece. I know that the student can execute and interpret the statistical results, but now this is where I'm looking for can they tell me what this means? And so I've kind of highlighted the points. Perhaps the student wrote a little more than maybe I would have written, but they identify based on the coefficients in the model that they see from the model that people who identify as independent or neither are less likely to be frequent voters than people who have a party identification. But the model also showed that Republican and Democrats actually had fairly similar voting behavior. And so they saw this from the resulting model output that they selected. And so again, in this piece, what I'm really looking for is, can you get from just, I've done the technical execution, we've fit the new model with party ID, but can you tell me the results in a way that might be suitable for, let's say, the 538 audience, who may just be like a general audience? And so really, again, this is an example of, getting students to think about the effective communication piece. And so I'll move on to the next skill, collaboration, in which you'll actually see that communication piece come up again. And so what we see here is the front page of a training manual for IBM. And they said, data science is a team sport. Do you have the skills to be a team player? And I just love this idea of data science being a team sport. I think that's a great way to describe it, given the interdisciplinary and collaborative nature of the work. And really, just like the other skills we've seen so far, you could plug in anything there and any job, any discipline, and I think this would still apply. And this is something that's clearly important because IBM had a whole training manual dedicated to just how do we work together on data-driven work. And so why is it important to incorporate teamwork? And I would even put their effective teamwork into our courses. And really, overall, this models for students the collaborative and interdisciplinary nature of what this work looks like in practice. So again, as educators, we know that there's lots of collaboration in the work that we do. And when students go to, again, their careers, even if they're doing data science work and they're the only data scientist on the team, they're going to be working with the business analyst, perhaps project managers, a whole group of other people. So they'll very rarely does work occur in isolation. I think there's also a set of skills that incorporating teamwork helps students develop. It helps them develop those communication skills. And so in my courses, because I teach fairly large courses, this is really where the oral communication piece comes in. As students are discussing problems with their teammates and they're exchanging ideas, they have to really sort of work out the kinks and how they're communicating about statistical results and talking about the data as they're interacting with one another. It also helps them develop interpersonal skills. Any team that works together long enough at some point will probably hit a roadblock or there will be some sort of conflict. And so by working together on teamwork in the class, that gives students an environment to begin to learn strategies for dealing with that interpersonal conflict that inevitably will arrive. It also helps students learn how to work with a really diverse group of people. Again, people with diverse opinions and experiences and perspectives. And also from the computing perspective, it helps students learn the tools and how to navigate computing for collaborative work. And so developing strategies for if we're all working on the same data science project on our own separate laptops, how do we work in a way that's effective? In my course, we use GitHub. And so this is the portion in which we're really teaching students how to collaborate effectively with GitHub. But then there are also, those skills, again, kind of going back to that core statistical content that are actually enhanced by effective teamwork. So students are enhancing their statistical reasoning skills. They're enhancing their problem-solving skills, their critical thinking and conceptual understanding. Again, as they're having conversation and debate with their teammates, as opposed to working on things in silos. And so I'll share some strategies and give you an idea of what the teamwork piece looks like in my courses. So I form teams very early on in the semester, usually right after drop add and the enrollment has settled down. And my students fill out a survey, like a get to know you survey, that includes questions such as what's their previous statistics experience, either in high school or at the university? What is their computing experience? What is their intended major or academic interest? Because I usually have students before they've declared a major. Maybe even what are some of their hobbies or other things they're interested in. And so I use that and other information to help form diverse teams. And when I say diverse, I mean diverse in a lot of ways. Diverse perhaps in previous statistics experience. Perhaps someone's had a lot of applied experience. Someone else has had a decent amount of theoretical experience. Perhaps I put them on a team to balance that out. Diversity in their computing background and how comfortable they feel with the computing tools. Sometimes I have diversity of academic interest, but sometimes I also put students with the same interests together because sometimes that tends to work out better perhaps for the final project. But really diversity, you could think about that in a broad sense, like whatever makes sense in the context of your students. But the caveat to that is avoiding isolating students, particularly when you're developing teams, isolating students from historically marginalized backgrounds. So when I do form teams, I do try my hardest to ensure that every student has a point of contact or connection with at least one other student on that team, so that they don't feel like, oh, there's 3 people who are just alike and I'm here by myself. One thing I do is keep the teams consistent. So the teams are formed about week 3 of the semester, and they stay on the same team until the end of the semester. And doing this over the course of about 6 years, I think I've only had to disband a team one time because it just was beyond repair. But by keeping the teams consistent, again, one, we're modeling for students what they're going to experience once they get out into the workplace. Once they start doing research or their internships or their jobs, they're more than likely going to be on a team, at least for the duration of a project. And so, again, by keeping the teams consistent, students are getting an opportunity to develop those interpersonal skills, get through the roadblocks together as a team. Another one I've learned throughout the way is providing students guidance on how to work on a team. So students actually naturally don't come in knowing how to work on a team, and particularly how do they work on statistics or data science work that they're just learning in this team environment. And so we talk about the value of teamwork, as well as some strategies such as team or roles on the team, some sort of mapping for workflow to help students figure out how to work on a team. And I provide a lot of scaffolding at the beginning of the semester, in particular with the computing piece that is a part of my course. And then as the semester progresses, the students have sort of figured out a flow for their team. The next is incorporating regular peer feedback. And I think even more important than the peer feedback is the self-reflection. And so every few weeks, I have students fill out some sort of peer evaluation where they're kind of talking about the contribution of the team members and if they're what's working well, what's not working. But I also have students reflect on their own contribution to the team and what they think they're doing really well and what they think perhaps they could improve on. And what I have found, particularly about the self-reflection piece, is that for the students who may be on the outside perceived as like the loafers or they're disengaged, it's usually in that self-reflection piece where they're either like owning up to it, like, hey, I've taken a really hard semester and I just haven't had time to do this, or perhaps they're reflecting on, well, these last few weeks I've been distracted and now I'm going to commit to working harder on the team. And so I think giving students an opportunity to reflect on their own work has been a really important piece of the teamwork. Another one that seemed kind of unintuitive to me at first was really dedicating time for teams to work together during class. So a lot of the teamwork in my class happens really outside of class as students are working on assignments or working on the final project. But now I've been more intentional about dedicating time for the lab teams to work together during lecture. One, this is just like another level of accountability for the students if they know they're going to be doing work together during lectures. But another piece of this is that it gives me an opportunity to observe how the teams are functioning. And so if there are teams where in the peer feedback, it looked like, oh, this person's not engaging, this gives me an opportunity to observe and perhaps, though at times it seems awkward, perhaps intervene and say, oh, well, what do you think about the problem that we're working on, or somehow try to navigate that. But also if there is need for further conversation, this gives me a chance to have that conversation based on my observations, as opposed to dealing with that tension of, oh, I don't want someone to feel like their teammates are tattling on them. So I can approach the student as, oh, I observed in class today, perhaps you weren't as engaged or something like that. And then the last strategy that I have found for teamwork is really starting with a team agreement. So the first thing students do as a team is come up with a team agreement. These are also called team norms or team charters, where they, one, come up with a fun team name, but then they also walk through a document that helps them think through issues such as How are we going to communicate? Are we going to get in a group text, or are we going to communicate on Slack? Or what is a dedicated time during the week that we all know we're available if we need to meet outside of class? We also talk about, well, what do we do if we can't come to a meeting, or we're unable to get our portion of an assignment done during when the team expected? And so I have found that the team agreement, one, just really helps students proactively think through how to resolve potential conflict, because things are going to come up during the semester. But again, this provides another method of communication for me, that if there is a time in which a team needs further conversation, I have the team agreement to rely upon, and we can use that as a starting point for the conversation. And so those are just some of the strategies, again, that I have used for doing the effective teamwork in the class. And I think this piece, which admittedly at once probably kind of started as a way to deal with the size of my class, I think has really become a nice piece of the learning opportunity for students, because there is so much complexity really that goes in working with working on a team, particularly when you're doing it for like the first time or new to a discipline. And so the last one of these areas I'll talk about is ethics. And so ethics is one of those things that when it's going well, you don't really hear about it, right? Ethics, when it goes poorly, that's typically when people really start thinking about ethics. And so this is just an example of some of the ethical issues that have come up in data science, or perhaps not so related to data science directly, in the past few years. So there was Cambridge Analytica. This was a company in which they were basically, without consent, grabbing millions of people's what they thought was private Facebook data, and using that for political targeted ads. And in a recent interview, the former COO said that they made ethical mistakes because they were too focused on the law and not thinking about what was the ethical process, not just legal. There was an example in 2018 in which a governor released lots of data about how people used social services and welfare. And they released this data, I think it was anonymized data, but basically line by line data, and use it to sort of, again, in a politically driven way, craft a narrative about people who are using social services. There are a myriad of issues with AI coming up. And so I feel like every week there's something new about thinking about what data is going into AI, or people being unaware their data is being used for AI, and sort of grappling with, well, what are the ethical issues there? But this article also in the Washington Post really goes into, well, sometimes it's hard for people to make an ethical decision because there's perhaps not enough data documentation to say, well, what are the fair uses of this data? And then the last one is not necessarily related to statistics directly, but we've all heard about the myriad of issues at Boeing. If you're like me, you're now more aware of the type of plane you fly on every time you book a plane ticket. And so again, even if our students are not going directly into statistics or data science, these idea of making ethical decisions comes up constantly in the workplace, and really as they're just navigating the real world in general. The good news is there are lots of people thinking about this. Companies like McKinsey had documentation about what it means to do ethical data science. There was popular outlets such as Slate, which is just like a mainstream non-technical outlet, had multiple articles actually about what it means to be an ethical data science or do ethical data work. Professional organizations like the American Statistical Association has guidelines for ethical practice in the discipline. And then again, outlets like Harvard Business Review, again, provides guidelines and some guidance of things to consider in regard to ethical practices. And so when I think about ethics, in my brain, I think about it in sort of two different buckets. There's the like what you're doing, and this is specifically as I'm thinking about data science ethics. So these are the things we've probably thought about: data security, data privacy, honest reporting. Am I interpreting the results in a way that's fair and ethical? Is my graph fairly representing the information? Algorithmic bias. So I really think of these as the analysis decisions that we're making. But then there's the how you're doing it. So are you doing the work in a transparent and reproducible way? Again, back to this collaboration piece. Are you treating others ethically, both in the people you're collaborating with, but also the subjects who may be represented in your data set? And so I'll provide a brief example of sort of how I've discussed these with students, both the what you're doing and the how you're doing it. So the first is the what you're doing. This is an example that was originally developed by one of my teaching assistants who was very passionate about data ethics and eventually moved on to get a graduate degree set in understanding computer algorithms and ethics. And so here's an example where we have two individuals. They both have the same credit score. They both have the same income. But the first one has green hair and a green shirt. And the second one has blue hair and a blue shirt. Otherwise, they're completely identical. We find out through some further analysis that hair color and shirt color are direct proxies for race and zip code. And so we all know that particularly in areas such as banking and lending, you're not legally allowed to use race and zip code in like a model to determine whether or not to give someone a loan or something. But what are the ethical considerations of using hair color and shirt color? Those are technically legal. So we don't have perhaps the legal considerations, but is that ethical? And so we have a discussion. I've done this one in my introductory data science course, where students are talking about the ethical considerations of using hair color and shirt color. I love this example because it's sometimes a little easier to navigate what can be some very tough and tricky conversations, particularly in a large class. This sort of breaks the ice a little bit because we're talking about hair color and shirt color. And so it sort of lightens, it's silly enough that it sort of lightens the tension, but it also really gets to the meat of the issue. And so after students have sort of grappled with what are the ethical considerations here, we tie this back to a real life example in which something like this happened. And so we talk about redlining, which was a practice in the mid 20th century in which basic neighborhoods that had a high percentage of Black residents were considered ineligible for government-backed mortgages. And so after the Great Depression, the government had a program in which they were trying to encourage people to purchase homes and sort of rebuild the economy. And they would create these red line zones. You can see what the red zone here is, in which they considered this an area that was considered hazardous or not eligible for the government-backed mortgages and other financial resources. And these neighborhoods, though not explicitly stated, were neighborhoods that had they were either integrated or had really high percentages of Black residents. And so they were using all these other criteria to ultimately hide this idea that they were segregating based on race and who they were considering eligible versus ill-eligible for these services. And so again, this is kind of tying that where we were originally talking about hair color and shirt color to really grapple with those issues. Again, we tie this back to, well, here's what this looked like in real life. And even though redlining has officially been considered an illegal practice, right, there are still ongoing implications of this to this day. And so that was an example of the what you're doing. What are the analysis decisions that you're making? And so the second piece of this is the how you're doing it. And so one of the big things that's, again, come up over the past few years is thinking about AI. Students have access to tools like ChatGPT. And so what do these look like in our courses? And how do we teach students how to think about these tools or use these tools? And so one thing I've implemented in my courses is an AI policy. You don't have to read this whole policy here, but this is a policy that I developed in collaboration with colleagues in my department on getting students to think about, well, how can they use AI in the course. But part of the policy and what we talk about in class is that as they're thinking about using AI, there are really two different dimensions in which they should consider using the tool. And these were adapted from a document written by Joel Glad. The first is the cognitive dimension. So as you're considering the use of AI, using it in a way that could facilitate rather than hinder learning. And the ethical dimension. So being transparent about how you use it and making sure it aligns with the academic integrity policy for that course. And so in my course, the policy states that students can use AI for code. So I do allow students, if they want to refer to ChatGPT for code, they can. However, just like any other internet source, if they're using it for code that's far beyond the scope, like what we do in the course, something they couldn't find in their notes, then they need to cite that as such, just like they would any other external resource. They are not permitted to use tool for narrative. So all those interpretations, writing the conclusions, they're not permitted to use AI in the course in that way. But part of this policy in my discussion with students is not just you can do this, but you can't do that, but talking about these guiding principles and really how to think about their use of AI so that hopefully they can begin to think as they move on to their other courses that have differing policies or as they move into the workplace. One, really, what are, again, some ethical considerations of these tools, but also how do we, again, do our work in a transparent and honest and ethical way. And so I'll wrap up with just a few final thoughts, kind of tying all this together and things I've learned throughout the way. The first is to start small. And so to slowly incorporate these other skills in your course. So where I've gotten to now is sort of slowly incrementing these over multiple semesters. If you're like me, I leave conferences like eCOTS wanting to try 10 different new things, but really slowly incorporating these in your course. The next is really being intentional. And I think so intentional that the skills that you think are important, making them part of the course learning objectives. I think a lot of us are already talking about these things or doing these things with our students, but putting them as part of the course learning objectives, one, communicates to students the importance of these, but two, as an instructor, holds us accountable for ensuring, like, incorporating these in our curriculum. And so one of the changes I'm making in my course in this upcoming semester is including ethical reasoning as part of the core learning objectives in the course, being more intentional about the weight of that subject in my courses. The next is explaining why. So in addition to incorporating them in the learning objectives, explaining to students why this is important. When I first started doing a lot of the writing work in my class, I got lots of pushback from students about, why do I need to write? This is a statistics course. And I explained to them, based on my experience in industry and experience from former students, the importance of written and communication in this work. And then the last one is being open. So being open to try new things and get student feedback. I have done plenty of things throughout the years that have just completely fallen flat. And if you ask students, they're not shy to let you know. And so just being open to trying new things, thinking outside the box, but also getting student feedback early. So at a minimum, I do a mid-semester survey in which I figure out sort of what's helping learning, what's hindering learning. Or if I try something, an assignment or a project that I think is, I'm just really curious how it goes, I ask students for feedback sort of afterwards on that specific project. And I found that students do provide really constructive feedback. I think, one, if the questions are worded in a way that would facilitate as such, but I think they also appreciate, and it helps with the buy-in, that you care about sort of their learning experience. I also know 2 course evaluations are a really important piece of our evaluation and career. And so getting the feedback early also hopefully hedges against perhaps just getting unexpected or unhoped for evals down the road. And so again, I leave you with these 4 skills Again, all with the goal of helping to bridge the gap between what students experience in our classroom and what they experience in the quote unquote real world. But the reminder that given the content we need to teach, the realities of teaching in a semester and students taking other courses, right, that this is work that we're doing incrementally. We're not going to make the leap all at once, but we can make small changes in our course to help bridge that gap just a little bit. And so thank you for joining today. I look forward to questions. My slides are available at this link. I can also put it in the chat. And thank you.
Thank you, Maria. We do have a few questions here in the Q&A. One person asked, Kara said, while it's stated in your AI policy, do you have any way of making sure that students are not using AI for narrative in course assignments? Are you concerned about this or not too much?
Yeah, that is a really good question. I do not use like any sort of, I know there are some like automated track, like detection things. I don't use things like that. I probably don't look for those things enough. I have had instances in which it was kind of obvious that students used some sort of chat GPT or something because it kind of gave this really long answer that didn't actually answer the question. And so in that case, I had a conversation like with the student and kind of got to like, okay, yeah, this was some sort of AI tool, but I don't do any sort of, I don't have like a process in which I detect those things.
Thanks. Karen asks, says, wonderful talk. Is your team agreement assignment available to share? And thank you for the session.
Oh, yes. Yes, my team agreement. Let's see, this is kind of a perhaps. Actually, I will post the link to where some supplemental resources from a paper I wrote about one of my courses is instead of giving the rigmarole. But yes, it is available.
Have you, anonymous attendee asks, have you used the teamwork strategy on online blended courses? If so, do you have any comments or concerns?
So the only sense in which I've used it in an online or hybrid course was just like during the pandemic. So not in a course that was intended to be online and admittedly not a well-designed online course, but in the kind of emergency remote learning situation. And really, to be honest, it was that made me start doing the team agreement because then we also had to grapple with time zones, computer access, and sort of all of these other things. So I think in my experience, my very limited online experience, just hammering out those logistic issues that exist in the online environment that aren't necessarily as present on campus were really important for the team agreement.
We have a few more questions, a couple short ones, and I'll save the longer one for the end. Earlier, someone had asked, does it benefit the art historian more to have training in more general software like point and click than typing their first experience with stats concepts weaved in with trying to learn coding? So setting aside the reproducible audible workflow issue.
Oh yeah, that's an interesting question. So I think kind of two thoughts on that. I think even for like the art historian, there's actually really interesting work that you can do with the computing tool. So I know as part of the data science in a box curriculum developed by Mina Chetankai-Randell, there's an example actually that's looking at lots of historical records from like art auctions. And so there's actually really interesting statistical work that the art historian can use utilizing the computing. But I think probably what the question intended, I think, even if the student is learning the computational tools, and even if they're, in my case, we use R, even if the student is not going to use R directly in their art history work, there's lots of learning and like computational thinking, troubleshooting, problem solving that the students are also learning as they're learning computing, almost in the same way that they get from learning math. That they can translate into then sort of learning, whatever software perhaps they'll use in their art history work.
Someone asks about their perspective on group work. I teach a large group-oriented course and use many of the practices you shared on how to promote productive group work, except that I don't keep groups consistent. I think that you made a great case for why that should be the case. I'm curious to hear if you've tried having groups that change through the term. Maybe if you have one major project, this doesn't make sense. As I've found that there are many benefits of having students meet more people, build classroom community, and learn to interact with various types of people. But I've also seen students frustrated with the lack of consistency and how they perceive this to impact their learning. Curious to hear your thoughts.
Mhm. Yes, that's a great question. So in my experience, I've kept the teams consistent, like the core teams, partially because ultimately they work on a final group project, and I want them to learn how to work together before they have to do this really large task. But one way in which I do give students experience working with others is sometimes during lecture. Like, I don't always have students working with their teams during lecture. And so sometimes I'll do the random, like, number off, 1 to 10. And so, or in some other way, randomize the work. So they're at least getting little snippets of working with other people in class.
We've had a whole lot more questions come in, so there's probably like 5 more. So we'll just try to get through as many as we can in these last couple minutes.
Okay, I'll also try to be brief.
Yeah, okay. In regards to computing, based on your industry experience, what are the top 3 professional tools, statistical software, a new grad should have, uh, a new grad should have a good working knowledge of? And how is that different based on their job title, like junior data scientist versus junior marketing manager?
Mm-hmm. I will say, so based on my experience, that it was over 10 years ago, so it is very different. But based off of students, and there was also a large survey, I think you can find the data on Kaggle of data scientists. Most data scientists are using Python and R, but I also have a lot of students who go into finance in New York and they end up using Excel. So, but I think but they're not data scientists, they're like financial blah, blah, blahs. But I think the two biggest ones based on survey data and anecdotal data and data science are, I think, Python definitely, and then R.
Do you require students to use Quarto or R Markdown? And if so, how do you get student buy-in?
Yes, we use Quarto. We were using R Markdown, and now we've transitioned to Quarto. Really, the first day of class, they open up a Quarto document. Like, they see a Quarto document, and also being able to write reproducible reports is, again, a learning objective. And so I've actually not had a ton of pushback on using that tool. I think just because from day one, it's like, this is just how we're going to interact with data and statistics.
All right, and one last question, squeeze that in. What size of course do you teach, and how would you implement this at scale?
Yes, so a lot of my course, I typically, like, a lot of my courses are around 100 or so. So I've done this at some scale. I know some people are teaching hundreds of students. So a lot of this I've done with about 100 students. I've also taught classes as small as like 10 or 11, but a lot of this is done in some scale. I think the hardest piece to scale up is the writing piece. And so if the more students you teach, I think grading writing becomes much more challenging. And so I have found having short writing, which is why I tell students only 3 to 5 sentences, has been really helpful.
Excellent. And we will end it on that. Thank you so much. Oh,
I
Maria.
will just say, I will post a link to supplemental. It's a link that has a repository of some of the assignments I showed today, as well as that team agreement that someone asked about.
All right. Thank you, everyone. We'll see you in the next session.